real fast is just review where you were at. Power to power, what do you do with the exponents? Multiply, good. What do you do with the exponents? You plus them. Yes, you plus them. Okay. What if it is not happy?
Switch it.
You fraction it?
Yeah, you fraction it. I like that.
Yeah. Jump aboard. And then if it's not happy in the denominator, you unfraction it? Very good. That's good, I like that one. And then we had all the rules about playing war when you had division. Okay? Excuse me. When you had same base, different exponents when you're using division, you just played war and simplified. So the reason why I just say play war, if it's a 6 up top and a 2 on the bottom, the 6 wins, so you just subtract it. Whereas if it was a 1/2 on the bottom and a 4th in the top, the 1/2 would win, so it would go to the bottom. Okay. The rules didn't change once we threw things in with fractions. They just started to look a little bit weird. Okay. From there, it was just a lot of simplifying that we did and going through it. 7.1 and 7.2 were just basically your exponent rules, and then as well as some very simple, like the cube root of 27, things like that. What are the factors you make themselves work? What's nice is that as we get a little bit longer into this one, we start to get to the equation stuff, I'll show you some nice little tricks that you can do if you had a calculator to be able to do some things. I'm not worried so much about it yet. But let's talk about where this is going to go with today. Today we're going to talk about function operations. Adding two functions together, subtracting functions, multiplying functions, dividing functions. Basically, this just means I'm going to give you two functions. And I'm going to ask you to add them together. I'm going to ask you to subtract them. I will ask you to multiply them. And I will ask you to divide them. Basically, this means it is direct substitution. If it asks you to add two functions together, that's where they get this f of x, g of x. F of x is function of x. G of x is g is a function of x. Things like that. Excuse me. Yeah, it's just called function notation. Yeah. It's really all it is. So if I want you to add these two together, you would take 2x plus x plus 1, and what do you get? You get 3x plus 1. Yeah. It's nice to see some normal stuff for a change.
Okay.
All right. Now, when you go to subtract, though.
Oh no, this doesn't sound good.
Oh, it's not that it doesn't sound good. Notice how they read it out. F of x minus g of x, which means you have to subtract the whole thing, which means you have to distribute this subtraction. And that's usually what you guys would forget. What happens here is you're subtracting that secondary function. If there's two parts to it, you guys tend to forget to distribute the negative. Okay? It's very common. You see it all the time. So you just distribute the negative, and you'd get 2x minus 1, and your answer would be x minus 1. Okay? What do you do if you multiply? Well, exactly, you just multiply. It's distributed. And you get 2x squared plus 2x. And last but not least, dividing. You just divide them, right? It's 2x over. Can I simplify that at all? No. Sometimes you can, sometimes you can't. It just depends on the problem. what the two functions they give you to start with. Sometimes you might be able to factor something, you might get a GCF here or there, but in this instance here, that's the only thing that would do it. Is there a domain restriction for the division?
Yes. I'm guessing yes.
What is the 0 of g of x? -1, good. X can't be -1. A lot of times they will ask you real quick, what is the domain of a composite function like this, when you're putting two functions together? They'll ask you for the domain. Obviously the domains of these first three are going to be all real numbers, there's no restrictions. But the minute I throw in a division here, can I ever divide by 0? No. So usually that just means at the very end of this one, you'd have to say that x can't equal -1. Does that make sense? There is this. Function notation and function operations are something that shows up over and over again. If any of you guys have taken a practice ACT or the ACT, you've probably seen some of this stuff before. Okay. It's very common. They actually don't even, sometimes they'll use a triangle of x and triangle of x and things like that to try to throw you off. But it's all function notation. When we get closer to the, wait, isn't, oh that's right, we don't do the ACT anymore in school. Never mind. I will backtrack that out. Just nod and smile. They don't do it in school now, you have to just do it on your own. The state will pay for it. Why? State doesn't have a budget. I know. Welcome to Illinois. And I just found out this, that your driver's license, when you get a driver's license, is not going to be valid for going through an airport. It's not secure enough.
What's not secure?
They'll make you buy a $180 passport.
Well, that's not good.
I agree.
It's not secure.
If you're going to
I don't know, it's pretty secure to me.
I heard something about the driving age work up to 18.
No, they say that it's too easy to, the Illinois driver's license is too easy to copy. I don't know. Hey, I'm with you, okay? We're going, yeah, I'm not happy about this stuff. Anyway, what's going to change with it today is that we're going to incorporate it with fractional exponents. But do any of the rules change? No. So if I have two functions, f of x is 2x to the 1/2, and g of x is -6x to the 1/2. When I go to do the addition part, I still do the same thing. I'm going to change the cut up here, sorry. We still get the same idea. It's 2x to the 1/2 plus -6x to the 1/2. Now, do those guys have same base, same exponents?
Yeah.
So what do you do?
Just
Combine like terms.
combine.
What's 2 plus -6?
-4.
Still got it. Nice.
Still got it. A little rusty.
And there you go.
I'm getting there.
-4 x to the 1/2. That's it. Okay. What do you think the subtraction is going to look like?
Same thing.
This same thing with the same change opposite thrown in there. So you have 2x to the 1/2 minus the -6x to the 1/2. And you get,
8x.
very good. I know a lot of your bodies that you're thinking, when is this going to get really bad?
Yeah.
It usually is. Once it starts going like this, I always see it in your eyes. You just kind of get that look of like, just get.
Do you like it?
All right.
I'm pretty sure he likes it.
Try multiplying and dividing with two different ones.
Okay.
Okay.
Bring it.
This is where you have to start remembering your exponent rules.
Why do I keep doing that?
So again, fill in the blanks. It's 3x times x to the 4th. Same base, different exponents. Way to do the exponents. Add them. What's 1 plus a 4th?
5/4.
5/4. Good. So this is 3x to the 5/4. Okay. Second one, you have to divide. So it's 3x over x to the 4th. And now you have to play the game of war. Who wins? The 1 or the 4th?
The one.
One.
So what do you get when you take 1, subtract the 4th?
3/4.
3/4.
Huh?
I don't know. Eventually. It does show up.
Because this is
Compositive functions. You have probably seen this written a little bit differently.
Okay.
For example, you might have seen it written like this before, maybe back in algebra. You ever saw this in geometry? No, I know you've never seen this in geometry. Compositive functions basically means you're going to take one function and substitute it into the other function. Now, if I'm looking at this, it says it says f of x is 2x plus 1, and g of x is 4. What I wrote down below that then was what is f of g of x. Now, if you think about just plain old boring order of operations, the order of operations tells you to go to your parentheses first. Do you agree? Well, the innermost parentheses on this one is basically g of x. What is g of x? 4. So this means I'm going to take whatever this is and substitute it in to here. That's what that meant. And you might have done that before when you saw stuff as this. You had f of x is 3x minus 1, g of x is x plus 2, and then you would see these types of questions. What is f of negative 1? What is g of 4? What is f of 0? Do you remember seeing that?
Yeah.
That's a composite of a function. It's telling you what function to work with by substituting in. Bailey, you look like you're going crazy. What is it? You sure? Okay. What these problems did in the past would just basically tell you, well, this tells you which equation you're working with, the f or the g equation. F, because this is the letter F. Okay? So it's telling you to work with the f equation and substitute in negative 1 for x. So you get 3 times negative 1 minus 1, otherwise known as negative 4. G of 4. Do I work with the f equation or the g equation? Because this is the letter G. So, what's 4 plus 2? These are still that same basic idea. Okay? What we're working on is innermost parenthesis, build yourself out. Function notation, f of g of x, g of f of x, f of x, it's all the same basic principle. What we're going to do is this. We're going to take the composite of two functions, bless you, and we're going to find the 3 different ways I can, well, 3 examples. I got 2 functions. F of x is 3 x to the negative 1, and g of x is 2x minus 1. And what we do here, guys, is we always work with the innermost parenthesis, and you take whatever that function is, and you place it in for x at the other one. So in the first example, what is f of g of x? Tells me to work with which equation first? The g of x. So what I do is, I take the g of x equation, and now I'm going to surround it with the f equation. Because I'm taking this value, and I'm substituting in for x. And can I simplify that? What do you get? Ah!
Oh, you
One
have to
over
just-
6.
No!
One, is it 1 over?
1 over 6 negative 5.
What is being raised to the negative 1 power?
The 2x minus 1.
Wow.
So is it 3 over?
It's not the whole thing.
It's 3 over 2x plus 1.
All the way around.
Minus 1.
This part is what's not happy.
I'm not happy.
That's how that works. The stuff in the parentheses is not happy. Okay. You cannot distribute into that because it's got a negative 1 power. You're going to make it happy before you move anything around. The 3 was fine. 3 was happy and content. It just it was not raised to the negative 1 power. If it was, it would have been written like this in the original equation. Does that make sense? Since it didn't have parentheses grouping it to the negative 1, this implies that it's just this part is raised to the negative 1. Okay.
Okay.
Does that make sense?
Yeah.
Okay. You do the same thing with the next one. Next equation says start with the f of x equation and then surround it with the g of x equation. Well, surrounding this would be taking this value now. Let me erase this. Taking this and substituting in here for x. So then I get times 2 minus 1.
2 minus 1.
Okay. Well, what I want to do right off the bat here is make that x value happy. So I'm going to rewrite this. And what do you get? Very good.
Yeah.
You get 6 over x, all subtract 1. Again, the x value is one that's not happy, not 3. 3 stays there. Okay.
Why
And
don't
the-
you- why don't you just move the 3x to the negative 1 down?
What's not happy there, the 3 or the x or both? Again, is there parentheses around the 3x?
Yes.
No. The only thing that has the negative 1 power is the x.
Okay.
This is the only part that's being raised to the negative 1. If it was, it would have parentheses like this. That's why it's a little different. Okay. And then last but not least, we have f of x. You can have g of x. Well, there's more. You can have g of f. Yes, you can. So you start again with the 3x to the negative 1, because that's the f of x equation. And then you surround it as it was x. I took 3x to the negative 1 and I substituted into x into the 3x to the negative 1. Okay?
All right.
Now you have, what's that? What do you mean it disappeared? Well, watch what happens. You get 3 times 3 to the negative 1, and then x to the positive 1. Because you distribute, you get power to power. Okay? So the answer here is
I don't like
x.
this. Oh, okay.
Once again, the reason that this works is that you get 3 times 3 to the negative 1, x to the negative 1 to the negative 1. This gives you 3 times 1/3 times x. That's how that works. Okay? Because you're using the power to power. You're using the distributive property of the exponents. We have to send it to both parts within the parentheses. That's where all those power rules and stuff from 7.1 come back to play. Going back into that, looking where what is being grouped with parentheses, what is not being grouped with parentheses, and so on. Okay? So here, you have f of x take a couple minutes and go through those 6. Those are a little bit larger, as you can see. And then I'll do another. If you go through the subtraction one, what you'll screw up is you'll forget to distribute to both parts. So you should get 3x plus 1 for the subtraction. Okay. Multiplication, distributive property. Exponents don't work all that badly here. So you have 4x squared minus 4x. Okay. Division, 4x over x minus 1. Anything you can do with that?
No.
Nope. Go to the next one. Function, composite of functions. F of g of x. Start with the g of x equation, x minus 1. And then now you're taking this part and you're substituting it in for x. So you surround it with what's left. So you get 4x minus 4. Oops. Okay? And then going the other way, you just start with the f equation, which was 4x, and you substitute it in for what the x was. And you're done. Okay? The weirdness really does lie within when you have the fractional exponents with composites, when you're putting in one for another. So let's try these two. What I have here are 2 different problems. F of x is 3 plus x all to the 1/2. G of x is x squared plus 1. Excuse me. And I'm going to do the composites, f of g of x, and then we'll do the g of f of x. Okay? So to start with this one, I'd write down what is my g of x equation. Well, my g of x equation is x squared plus 1. And what I'm doing here is I'm taking this value and I'm substituting it in for x, which means I need to surround it then with everything else. Okay? And now I combine. I get x squared plus 4 all to the 1/2 power. Which means you distribute that exponent to both parts. X squared to the 1/2 is what? X. 4 to the 1/2 is? And then I would do the same thing, go the other direction. Going the other direction says to start with the f of x equation. When we start with the f of x equation, we write it down. 3 plus x to the 1/2. And then I surround that with the g of x equation. Well, the g of x equation is x squared plus 1, which means I have to put this, square it, and then tack on 1. So I have to distribute through power to power stuff. And that's right, yeah, because we have the power to power there. They drop out, and you get x plus 4. Okay. Parentheses, exponents. Go to your exponents because there's nothing you can do with that. That's why we're saying power to power. distribute that down, you're done. All right. So, you try. Same ones with this setup. All right. Take a second, go for that. Then I'll give you a few problems here and see how we did. So f of g of x. Start with the g of x equation, and then surround it with the f. Can you do anything to that? There's really nothing you can do there. Okay. And then if you go the other way, g of f of x. Start with the f of x equation. And then you surround it with. Is there anything you can do there? But I just left it as 2 times x to the 3/4, or did I have to leave with parentheses? Okay. Really all there is to a lot of this. Really what you're going to screw up more often than not is distributing the negative. You're going to forget to do that. But don't forget to. I'm trying to remember what I think if these are the ones I wanted to do or not. Yes, these will work.
Oh, no.
All right. So this is 7-3. Oh, start at 20. Start at 20. Sorry. Start at 20. 20. Start at 20. I'll change it.
Start at 20?
20, please. Yeah. I accidentally cut off a couple multiplication ones.
No. Let's not do that. Then can you cut it down to 2?
Okay.
I thought
All right. Wait, that's no, I said start at 20.
You always said mid-20s. Still don't make sense.
we work on it because it's much easier. Sorry. Alicia, that's what I just don't want to do it this week, so I'm